Hi everyone, today we will study about the correlation. Correlation, the study of relationship between two or more variables, is the most important in life. It is a common knowledge that change in our variable will affect the other. For example, when the price of a commodity increases, its demand increases. And on the other hand, when the price of a commodity decreases, its demand increases. The statistical device with the help of which relationship between two or more than two variables are studied is called correlation. Correlation. Introduction of correlation. Two variables are said to be correlated if the change in one variable result in a corresponding change in the other variable. The correlation is a statistical tool which studies the relationship between two variables. Correlation analysis involves various methods and techniques used for studying and measuring the extent of the relationship between the two variables. Correlation is concerned with the measurement of strength of association between variables. The degree of association between two or more variables is termed as correlation. Correlation analysis help us to decide the strength of the linear relationship between two variables. The word correlation is used to decide the degree of association between variables. If two variables x and y are so related, the variables in the magnitude of one variable tend to be accompanied by variations in the magnitude of the other variable. They are said to be correlated. Thus, correlation is a statistical tool with the help of which we can determine whether or not two or more variables are correlated, and if they are correlated, what is the degrees and direction of correlation. Definition. The correlation is the measure of the extent and the direction of the relationship between two variables in a bivariate distribution. Example, height and weight of children. An increase in the price of the commodity by a decrease in the quantity demand. So with the help of correlation, we can measure the degree of relationship existing between the variable. Correlation first developed by Sir Francis Galton, 1822 to 1911, and then reformulated by Carl Parsons, 1857 to 1936. The degree of relationship or association is known as the degree of relationship. Types of correlation. The following are the types of correlation: positive and negative correlation, simple, partial and multiple correlation, linear and non-linear correlation. These are the types of correlation. Positive and negative correlation. If both the variables are varying in the same direction, that is, if one variable is increasing and the other on an average is also increasing, or if as one variable is decreasing, the other on an average is also decreasing, correlation is said to be positive. If on the other hand the variable is increasing, the others is decreasing, or vice versa, correlation is said to be negative. If both the variables move in the same direction, so correlation is said to be positive. Some examples: height and weight, hmm, price and demand of commodity, hmm, family income and expenditure of luxury, price and supply of commodity, like that. Price and demand of commodity, sales of woolen garments and the day's temperature. Negative correlation is both the variable move in opposite direction. The correlation is said to be negative. So, price and demand of a commodity, this is the negative correlation. Volume and pressure of a perfect goods, sale of woolen garments, and the day temperature, and so on. These are the negative correlation examples. Simple, partial, and multiple correlation. When only two variables are studied, it is a case of simple correlation. In partial and multiple correlation, three or more variables are studied. In multiple correlation, three or more variables are studied. Simultaneously, in partial correlation, when we have more than two variables but consider only two variables to be influencing each other, the effect of the other variables being kept constant. It is called simple, partial, and multiple correlation. Linear and non-linear correlation. If the change in one variable tends to bear a constant ratio to the change in the other variable, the correlation is said to be linear. The correlation between two variables is said to be linear if corresponding to an unit change in one variable, there is a constant change in the other variable over the entire range of the values. For example, let us consider the following. For example, let us consider the following data: x and y, x 1 2 3 4 5, y 5 7 9 11 13, suppose. Thus, for a unit change in the value of x, there is a constant change in the corresponding values of y. 2 unit. Mathematically, above data can be expressed by the equation y is equal to 2x plus 3. So, the relationship between two variables is said to be non-linear or curvilinear. Linear if the amount of change in one variable does not bear a constant ratio to the amount of change in the other variable, that is non-linear correlation. Methods of studying correlation. Correlation having two methods: graphical method, algebraic method. Graphical method, that is scatter diagram, and algebraic method, Carl-Pearson's coefficient of correlation. Methods of studying correlation. The following are the methods of determining correlation: scatter diagram method and Carl-Pearson's coefficient. Scatter diagram. This is a graphic method of finding out relationship between the variables. Given data are plotted on a graph paper in the form of dots. That is, for each pair of x and y values, we put a dot and thus obtain as many points as the number of observations. The greater the scatter of point over the graph, the lesser the relationship between the variable. The scatter diagram implies the plotting of values of two variables on graph paper and then observe the movement the following points may be born in mind in interpreting the scatter diagram regarding the correlation between the two variables. So see here, if the points are very dense, that is very close to each other, a fairly good amount of correlation may high degree of positive correlation high degree of positive correlation be expected between the two variables. On the other hand, if the points are widely scattered, a poor correlation may be expected between them. So if the points on the scatter diagram reveal any trend, either upward or downward, the variables are said to be correlated, and if no trend is revealed, the variables are uncorrelated. If there is an upward trend rising from the lower left hand corner and going upward to the upper right hand corner, the correlation is positive, since this reveals that the values of the two variables move in the same direction. If on the other hand the points depicts a downward trend from the upper left hand corner to the lower right hand corner, the correlation is negative, since in this case the values of the two variables move in the opposite direction. Low degree or negative correlation. In particular, if all the points lie on a straight line starting from the left bottom and going up towards the right top, the correlation is perfect, all positive. And if all the points lie on a straight line starting from left top and coming down to right bottom, the correlation is perfect and negative. Interpretation. If all the points lie in a straight line, there is either perfect positive or perfect negative correlation. If all the points lie on a straight falling from the lower left hand corner to the upper right hand corner, to the correlation is perfect positive. Perfect positive if r is equal to +1. Okay, if all the points lie on a straight line falling from the upper left hand corner to the right hand corner, that the correlation is perfect negative. Perfect negative if r is equal to minus 1. The nearer the points are to be straight line, the higher degree of correlation, the farthest the point from the straight line, the lower degree of correlation. If the points are widely scattered and no trend is revealed, the variable may be uncorrelated, that is r is equal to 0. The coefficient of correlation. A scatter diagram gives an idea about the type of relationship or association between the variables under study. It does not tell us about the quantification of the association between the two. In order to quantify the relationship between the variables, a measure called correlation coefficient developed by Carl Parsons. It is defined as the measure of the degree to which there is linear association between two internally scaled variables. Thus, the coefficient of correlation is a number which indicates to what extent two variables are related, to what extent variation in one go with the variation in the other. A mathematical method of measuring the intensity or the magnitude of linear relationship between two variables was suggested by Carl Parsons, a great British biometrician and statistician, and is by far the most widely used method in practice. Carl Parsons' coefficient of correlation is calculated by applying the following formula. R is equal to sigma xy divided by n into sigma x sigma y. The symbol R of Rxy or Ryx is denoted in this method and is calculated by R is equal to coefficient xy divided by sx sy. So where COV is the sample covariance between x and y. Mathematically, it is defined by covariance COV is equal to sigma x minus x bar y minus y bar divided by n minus 1. Sample standard deviation of x is given by Sx is equal to sigma x minus x bar square divided by n minus 1 power of 1 by 2. Sy sample standard deviation of y is given by Sy is equal to sigma y minus y bar square divided by n minus 1 1 by 2, and x bar is equal to sigma x divided n and y bar is equal to sigma y divided n. If the covariance is positive, the relationship is positive. If the covariance is negative, the relationship is negative. If the covariance is 0, the variables are said to be not correlated. Hence, the covariance measures is the extent of linear association between considered numerical variable. Thus, covariance is an absolute measure of linear association. In order to have relative measure of relationship, it is necessary to compute correlation coefficient. Contact the formula for sample correlation coefficient. R is calculated by the following relation. R is equal to sigma x minus x y minus y divided by sigma x minus x square into sigma y minus y square root. So r is equal to x, sigma x minus x into y minus y divided by sigma x minus x square root, sigma y minus y square root. R is equal to n sigma x y minus sigma x into sigma y divided by n sigma x square minus sigma x square root. Properties of correspondence coefficient. The coefficient of correlation R is always a number between -1 and +1. If R is equal to +1 or -1, the sample points lie on a straight line. If R is small, close to 0, there is low degree of correlation between the variable. The coefficient of correlation is the geometric mean of the regression coefficient. The Persian's correlation coefficient cannot exceed 1 numerically. In other words, it lies between -1 and +1 symbolically. -1 is less than or equivalent r, less than or equivalent 1. In other words, r is equal to +1 implies perfect positive correlation between the variable, and r is equal to -1 implies perfect negative correlation between the variable. Correlation coefficient is independent on the change of origin and scale. Two independent variables are uncorrelated, but the converse is not true. Thank you.